Okay, so that the factors and the solids, two things that we are left with. Solids handout you people already have, and I'm sure you guys noted that down in your notebooks. First, we'll talk about the factors affecting equilibrium. But this is purely from IGCSE, so we won't need to spend too much time on it. Actually, there are one or two points that examiner asks in AS slightly different from IGs. उस पे मैं ज़्यादा focus करूँगा. So let's just list few points about these factors like temperature, concentration, pressure, and then I'll explain all these with examples like Haber process, contact process. So this temperature could shift or affect the equilibrium position, but it higher temperature affects the endothermic side. Higher temperature favors the endothermic side. I mean, if the reaction is endothermic in forward direction, so it would start going to the right side. And if backward is endothermic, so it would start going to the left-hand side and vice versa. Lower temperature favors exothermic side. Whereas one important thing is that increasing temperature increases the rates of all the reactions. In fact, this is a really important point. And this is what examiner don't ask in O-level. A-level, they really ask it again and again. Increasing temperature increases the rates of all reactions. I mean, forward, backward, overall सब increase होता है, but the endothermic side increases more. Hence, we say the equilibrium has shifted to the other side. So just like this, I list the important points about other factors too. वो आप note कर लें मेरे साथ, and then I'll explain them through examples.
Yes, sir.
जी बेटा. Now the effect of concentration is specific according to the side. I mean, if concentration is changed for reactants, the forward reaction becomes faster. But if the concentration of product is increased, then the left-hand side or backward reaction becomes faster. So increasing concentration or effect of concentration is specific to the reactants or products accordingly. That is, for example, let's say if reactants concentration is increased, then equilibrium would shift to, then equilibrium shifts to right hand side. Whereas if the product concentration was increased, then the equilibrium would shift to the left hand side. This is also like vice versa. The third important factor is pressure. So let's list that point also. I'm sure you remember that when you discuss pressure, the pressure is only for gases. I mean,
Yes, sir.
concentration and temperature for all the reactions actually, but pressure is only for gases. I mean, such reactions which include gases, only their equilibrium is affected by changing pressure. And for pressure, we look for the number of moles. That is the side with greater moles. The side with greater moles is like the one that is affected. Hold on, Lead is asking for password. I don't know. Let me check. All right, so let's get back. I've shared the password now. Now, for pressure, we look for the number of moles. The side with greater moles is affected, and the equilibrium shifts to the opposite side. Equilibrium would shift to the opposite side, and vice versa also for this. So, uh, those who have just joined, I've just started with the factors that affect the equilibrium position. I'm recording this lesson. I'll share it later. So you guys can, if you want, take a picture of this. Won't be able to hold it for long for writing part, but these are the things that you guys have done in IGs even. And one is like temperature and concentration, pressure. So I've listed how these factors affect the reversible reaction, and I'll explain them with all some examples here. The fourth factor is catalyst, and that hardly affects the equilibrium. You guys should remember that catalyst does not affect the equilibrium because, in fact, a catalyst increases the rate of both directions, forward, backward equally. So catalyst has no effect on the position of equilibrium. It's only in the presence of catalyst, the rate of reaction becomes faster. However, it affects affects the rate. I mean, in the presence of catalyst, yeah, the rate of reaction would be higher, greater. All right, so lead can't join. Let me text it. Now I can't respond to more text now. So I've just written the main factors which affect the equilibrium position: temperature, concentration, pressure, catalyst. टेम्परेचर में क्या है कि हायर टेम्परेचर फेवर्स द एंडोथर्मिक साइड and increasing temperature whereas increases the rates of all reaction forward backward, but endothermic side increases more. Concentrations effect is specific to the side. If you increase reactant concentration, then the rate of forward reaction would increase, while if you increase product, the rate of backward reaction would increase. Pressure is only for gases, and it affects the side with greater number of moles, and the equilibrium shifts to the lower mole side. Whereas pressure also increases the rates of all reaction. In fact, its effect is like temperature itself. Catalyst does not affect the equilibrium position because catalyst increases the rate of forward backward equally. Therefore, equilibrium position does not get affected, but the rates of reaction would increase in presence of catalyst and will decrease in the absence of catalyst. Now, let's just discuss all these factors with some example here. Now, let's say if I, for example, consider that Haber's process reaction. So this Haber's process is for making of ammonia where nitrogen reacts with hydrogen to make this ammonia. Everything is gas here, and this reaction is exothermic in power direction. I mean, you need to remember the delta H of this reaction is negative. So what we are discussing right now are the factors affecting equilibrium. I've listed some points about the main factors: temperature, concentration, pressure, and catalyst. All these are the concepts you guys have done in IGs. And now I'll explain all these factors using example of, say, Haber process, contact process. Now this is a balanced reversible reaction. Suppose if at equilibrium, and this reaction was at equilibrium, we disturb it by changes like temperature, pressure, concentration, and all. So let's say if temperature was increased, if at equilibrium the temperature is increased. Now the delta H given at the end of this reaction tells me the nature of my forward reaction, which is exothermic. Negative mean exo. Whereas the backward reaction will be then endothermic. If forward reaction is exo, then backward reaction will be endothermic. And that's a fact. Now, if I increase the temperature for this reaction at equilibrium, then what would happen accordingly? I mean, you will respond to the questions according to the questions asked. So if examiner says what happens to the rate of forward reaction, we would say rate of forward reaction increases, rate of backward reaction increases, all rates increase, but increasing temperature increases rate of endothermic more than exo. So equilibrium shifts to the endothermic or left hand side. So all these changes which I've pointed out, I'll list them here. Increasing temperature will increase rates of forward or backward reaction, both. But because the endothermic side becomes faster, we would say the equilibrium shifts to reactants. Equilibrium shifts to the left-hand side, reactant side. And when the reaction gets faster in the backward direction, that means more of reactants will be formed and less product will be formed. So as a result, what happens is that the concentration of nitrogen and concentration of hydrogen will increase because backward reaction was faster, and the concentration of product will decrease and concentration of ammonia will decrease because more of your product is now going back to reactants. So all these are the effects, in fact, which would lead eventually to a new state of equilibrium, because when you disturb a reversible reaction at equilibrium, then the reaction it responds in such a way that it could get a new equilibrium. I hope you guys remember it's a law called Le Chatelier's principle. So Le Chatelier's principle is, I'll write here its definition before I forget it. मैं इसको ऊपर लिख देता हूँ. All these factors that are listed on the left hand side here are according to Le Chatelier's principle. Now, Le Chatelier's principle is that if a reversible reaction is disturbed naturally by some physical change, so if reversible reaction is disturbed, then it responds in equal and opposite manner to get a new equilibrium. This is like Le Chatelier's principle that if you disturb a reversible reaction at equilibrium, it would respond in equal and opposite manner so that it could get its equilibrium back. So all these factors that I listed initially, main points, temperature, concentration, pressure, catalyst, they were explained by Le Chatelier's scientists. So over here, I've explained Haber's reaction and its effect, like the temperature's effect on the equilibrium of this. So let's say if this reaction was at equilibrium and I increase the temperature, so the rate of forward reaction would increase, backward would increase, the equilibrium would shift to the left side because the left-hand side is endothermic. And because more of reactants are formed, the concentration of reactants would increase and product will decrease. So depending on the question, you would respond accordingly. If the question is about rate of reaction, so you won't go to the equilibrium position. But if the question is about equilibrium position, you won't mention concentrations or rate. And if examiner specifically asks what happens to the concentration of ammonia, to specifically mention what happens to it. It's like decreases in this case. अब अगर मैं टेम्परेचर को opposite कर दूं, like if I increased की जगह if I lowered the temperature, then everything here will flip. I mean, the rates will become slow. Equilibrium would shift to the exothermic side. More product, less reactants will be formed, right? If anyone have a question here, you should ask, because using same reaction, I'll explain pressure, concentration, and catalyst also. By the way, Haber process की optimum conditions are required. I mean, you guys learned them in IGs. The optimum conditions for Haber's process, if I've not listed them before this, I'll write them here, is a temperature of about 450 degrees Celsius, a pressure of about 200 atm, and the catalyst used is iron. So the optimum conditions are the ones which give us the best possible yield for any reaction. And for ammonia making, these are the best possible conditions where the amount of money put is least and the amount of product to yield is highest. Okay, now let's say if on the same reaction, I increase the pressure, like Haber process may, if I increase the pressure, so for pressure, you would actually look for the number of moles, right? So the number of moles of reactant side is greater. The number of moles for the reactant side is greater than product. So let me write this point here. So let's just take another example. Suppose अगर हमारे पास contact process है, और contact process में uh, we have this making of sulfur trioxide, like sulfur dioxide gas combining with oxygen to make sulfur trioxide. And all these are gases here. So let's say if at equilibrium, pressure is increased. So if I increase the pressure, then what would happen, because the reactant moles are like greater than product, that's 2 plus 1, 3 moles, whereas product moles are only 2. More moles mean more molecules. So increasing pressure would increase the rate of all reactions. In fact, forward, backward, all will increase, because it's not just the reactant particles will collide more and product cannot. They all collide more, but the side which has greater moles mean more molecules will have more collisions. उनका reaction fast होगा. So rate of forward or backward both will increase. Will both increase. Whereas the equilibrium shifts to the right side, because higher mole to lesser mole जाता है. जब आप pressure increase करते हैं तो 3 moles to 2 moles. The equilibrium position shifts to right hand side or the product side. So when I get more products formed, the concentration of product would increase. We'll say SO3 increases while the reactants concentration decrease, SO2 and O2 decrease. अब ये बड़ा O level की चीजें हैं. In fact, normally I've seen students respond well about these concepts, but interestingly, even though they're O level and easy concepts, apparently, and you get a lot of questions in MCQs and theory paper even from this. And where I've seen students struggling mostly is when the question is about rate. Increasing temperature and pressure would increase the rates of all reactions, remember. But the side with more moles will be affected in case of pressure, and the side with lesser, like the side which is endothermic, will be affected by increasing temperature. Rest is all simple, like equilibrium position किधर जाएगी, left या right पे. अब कैटलिस्ट और कंसंट्रेशन को भी मैं एक्सप्लेन करता हूँ, बट आई वुड अगेन पॉइंट आउट कि अगर किसी का कोई क्वेश्चन है, डाउट है, आप लोग पूछ लें, बिकॉज आई डोंट हैव मोर स्पेस लेफ्ट ऑन इट एंड रादर यूज अ न्यू स्क्रीन. Okay, let's say if I take another example of any reaction, say hydrogen iodide, it dissociates into H2 and I2. And it's a reversible reaction at equilibrium. And regarding concentration, suppose at equilibrium, some iodine was added into solution. If examiner gives you some volume or concentration, you just need to ignore that unless some calculation is asked. Just check what's added. If iodine is added, you're trying to increase product concentration. So the reaction will respond in equal opposite manner. The rate of backward reaction would increase. It would try and increase the reactant concentration. Equilibrium would shift to the left. These are all the points we'll write here. So if at equilibrium, let's say only one of the product was increased, or maybe both were increased, it's almost same. Increasing both obviously will have greater effect. So increasing iodine would increase the rate of backward reaction more than forward. And the equilibrium shifts to the left-hand side. I mean, when the equilibrium shifts to the left-hand side, I'll start getting more and more reactant. The concentration of HI will start increasing. And after all these changes, all these responses, the reaction would get to a new state of equilibrium again. So the effect of concentration is very simple. It's like depending what side you have changed. But sometime examiner, what they do is they add something that's not even common to that reaction. Let's say if some nitrogen was added into it, or oxygen was added, or chlorine was added. So if I add any of these into this reaction, nothing of these three molecules N2O2Cl2 is common with this reaction. Maybe Cl2 could make it confusing for displacement concept, but otherwise oxygen, nitrogen, for instance, are not common to my reactant product, so they would not have any effect. तो concentration के case में sometime they give you something that does not link to reactants or product at all, तो उसका equilibrium position पे फिर कोई effect नहीं होगा. I will say no shift in the position of equilibrium. Catalyst, the fourth factor, catalyst, as I said earlier, has no effect on the position of equilibrium. Now let's say if we had this Haber process again, and we use this. Now instead of Haber process, if I'll take example of contact process, उसकी भी optimum conditions में list करता हूँ. I feel like I wrote the other day in class, but अगर नहीं लिखी तो हम लिख लेंगे. The temperature required is same, 450 degrees Celsius. Pressure is needed less, 1 to 2 atm. And the catalyst uses V2O5, vanadium pentaoxide, 5 oxide. Now let's say if this reaction is at equilibrium, and I just take out the catalyst from it. I mean, if I just remove the catalyst at equilibrium. So if at equilibrium, catalyst is removed, so what would happen? No effect on the equilibrium position, because catalyst increases or decreases the rate of both reactions. So in this case, if catalyst was removed, all rates will become slow. All rates of reaction will become slow, and eventually there'll be no effect on the position of equilibrium. And if you're asked why equilibrium position is not affected, we would say all rates forward backward become slow equally. जितना forward reaction slow होगा उतना ही backward slow हो जाएगा. And likewise, if the catalyst was missing in this reaction and I just come and add some catalyst into it, so adding catalyst would increase the rates of all reactions equally. And again, although the rates are increased, the catalyst, the position of equilibrium would not be affected. So these are all the factors that I listed, and sort of with example I've explained them. Again, if somebody has a question, आप लोग पूछ लें. Other than this, the factors which affect the rate of reaction वो आपने जैसे O level में भी पढ़े हुए हैं. उसमें एक सॉलिड सरफेस एरिया आता है बट दैट इज नॉट एफ इक्विलिब्रियम पोजीशन क्योंकि सॉलिड्स आर नॉट पार्ट ऑफ रिवर्सिबल रिएक्शन इन इक्विलिब्रियम. तो जनरल फैक्टर्स जो किसी भी रिएक्शन के रेट को इंक्रीज करते हैं या इफेक्ट करते हैं, उसमें एक तो आपको पता है टेम्परेचर है, तो रेट ऑफ रिएक्शन इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर. और इसकी अगर आपसे काइनेटिक एक्सप्लेनेशन पूछ लें तो वी वुड से दैट इंक्रीजिंग टेम्परेचर वुड इंक्रीज द नंबर ऑफ इफेक्टिव कोलिजन्स, काइनेटिक एनर्जीज ऑफ पार्टिकल्स इंक्रीज. As the number of effective collisions increase, the rate of reaction becomes faster. Then the rate of reaction is directly proportional to concentration also. And then again, when increased concentration are taken, higher concentration, there are more molecules in per unit area, more effective collisions, and then the reaction is faster. For pressure, again, it affects only gases. And if the reaction includes gases, so rate also increases by increasing pressure, because increasing pressure decreases the spacing among particles. And when the spaces among particles decrease, the number of effective collisions increase. Therefore, reaction becomes faster. Surface area or particle size is only for solids. And crushed and powdered form particles give us faster reaction because more particles are exposed for the effective collisions. For the catalyst, we know that catalyst affects the rate of reaction because it lowers the activation energy. It actually provides an alternate pathway for the reaction. And that alternate pathway has lower activation energy. That's how catalyst makes the reaction fast. So generally speaking, all these factors linking to any rate of reaction, temperature, concentration, pressure, surface area, is like for solids only. तो ये again as I said के normally students do very well in these concepts, but अगर इसमें किसी का कोई question है, doubt है, बड़ा पूछ लें. Now lastly I'll go to the PDF of solids, उसको मैं go through कर देता हूँ. और if I mean if someone would still have questions or doubts, तो you could ask me again. Otherwise या मैं आपको रिकॉर्डिंग भी पोस्ट कर दूंगा ये सेम वाली, या इसकी कोई और अच्छी रिकॉर्डिंग भी किसी को चाहिए होगी किसी भी टॉपिक की जनरली, I'll try and share them later when I'm free. Solids PDF that I gave you, and if you have copied it, उसको मैं इधर ओपन करता हूँ. होल्ड ऑन. Yeah, so this is the PDF that I shared for solids with you guys. Now, those who have copied it I mean, while you were writing, you would have seen that most of it is easy. This iodine is the only new lattice or crystal that you guys need to remember. The lattices of these solids have not been asked in structured paper for few years for sketching, but it could come. I mean, a student should be able to draw the cubic lattice of iodine. So the points that I've written here, you need to remember that iodine is a black solid. Its lattice is cubic, and the molecules in the lattice are held because of the weak van der Waals forces. So they see the dotted line that I've plotted a cube here. These dotted line refer to the weak van der Waals forces. And the circles here are iodine molecule. So we all know iodine is solid, and the shape of this solid is cubic. Now the face of each cube, for example, has 1, 2, 3, 4, and 5 molecule. The one is also in the middle is also iodine. So if you see all the 6 faces I've drawn, 5 on the 4 on the corner and 1 in the middle. तो आपने इसको इस तरह से थोड़ा practice कर लेना है. Recent papers में we don't see sketching of lattices a lot. थोड़े पुराने papers में आती थी. But these points that I've written, they're really important. ये MCQs में आपको help करेंगे. It's a solid that sublimes easily because the lattice is held because of the weak van der Waals forces. So when you heat it, the forces break, and the vapors of iodine formed are purple. Among all the lattices that I've shared, this iodine and ice is slightly new or different. आइस की डिटेल लैटिस हमारे सिलेबस में नहीं है, ओनली द शेप अराउंड यूनिट वाटर मॉलिक्यूल इज देयर. अब around water molecule, we got two hydrogens covalently bonded to water directly, and then oxygen uses both of its lone pairs to make hydrogen bonds with the side water molecule. Around each water molecule, the shape is tetrahedral. हमें पता है वाटर की शेप प्योर फॉर्म में बेंट होती है, बट इन आइस फॉर्म मोस्ट ऑफ द वाटर मॉलिक्यूल्स आर इन्वॉल्वड इन हाइड्रोजन बॉन्डिंग. तो फिर इसकी शेप चेंज हो जाती है. द एंगल इज लाइक 109 एंड शेप इज टेट्राहेड्रल. And one very important point for MCQs is that ice floats on water because of large number of hydrogen bonds. As when more molecules try and make hydrogen bonds, molecules start pushing each other away slightly because hydrogen bond is longer than covalent bond. तो एक मॉलिक्यूल को जब मैक्सिमम हाइड्रोजन बॉन्ड बनाने हैं तो वो एक दूसरे को थोड़ा दूर पुश करते हैं so that hydrogen bond can be formed. A bond cannot be formed if a molecule, if two atoms or particles are too far away, and then again it cannot be formed if they're too close because then repulsion would dominate. तो मैक्सिमम नंबर ऑफ हाइड्रोजन बॉन्ड्स जब बनते हैं आइस में तो उससे मॉलिक्यूल की स्पेसेस लार्ज होती हैं. दैट्स व्हाई द आइस फ्लोट्स ऑन वाटर लाइक इट्स डेंसिटी इज लेस. इसके बाद जो लैटिसेस एंड डायमंड ग्राफाइट ये सारे ओ लेवल वाले हैं. इसमें देयर इज हार्डली एनीथिंग न्यू. डायमंड टेट्राहेड्रल है. इट्स यूजेस आर लाइक बिकॉज इट इज हार्ड इट्स यूज्ड इन ड्रिल्स एंड कटर्स. You should be able to draw the lattice of these, although sketching कम आ रही है लेकिन आनी चाहिए. Graphite on the other hand is soft and opaque solid. The layers of graphite are separated by the weak forces. You guys have done all this. These are temporary induced dipole forces. Because the layers are separated by weak forces, they can slide pass on each other. Therefore, graphite is a lubricant. And because it has delocalized electrons, it's a good conductor electrode also. Silicon dioxide sand, it resembles diamond. That too is like a tetrahedral structure, covalent macromolecule large structure, where each silicon is bonded to 4 oxygen and each oxygen is bonded to 2 silicon. All these points you need to remember. MCQs के लिए चाहिए होते हैं. And lastly, NaCl is cubic lattice, where the attraction between the opposite ion are strong, ionic, electrostatic, and each sodium is surrounded by 6 positive and negative. So if you look at one face of the cube, here top face, for example, it has 9 ions, 1, 2, 3, 4, 5, 6, 7, 8, 9. उसमें 9 में क्या combination होगा कि 4 on the corner and 1 in the middle are same, maybe like sodium, और ये बाकी alternate हो जाएंगे. So each same type of ion cannot be together. इसको डिफरेंट करने के लिए फिर आप जब भी फेस ड्रॉ करें तो 4 ऑन द कॉर्नर एंड 1 इन द मिडल हैज टू बी सेम, और बाकी फिर आप जब ड्रॉ करोगे तो वो अल्टरनेट हो जाएंगे. अगेन वन शुड नो हाउ टू ड्रॉ द क्यूब और लैटिस, बट नॉर्मली ये स्केचिंग में आते नहीं है, कम आते हैं. Magnesium oxide's lattice resembles NaCl because it also has 1:1 for the positive negative ion. But the bonding in magnesium oxide is stronger because it has twice the amount of charges present on it. तो ये था सॉलिड्स का हैंड आउट. इसमें आयोडीन इज सिंपल मोलिकुलर सॉलिड. आइस इज giant covalent but molecular solid because the unit in ice are water molecules. Diamond, graphite, silicon dioxide are giant covalent atomic solids. इनमें units are atoms, carbon atoms or silicon atoms or oxygen atoms. NaCl is a giant ionic lattice. The units in these are ions, right? I have a class at 120. I know I just made it a little faster, but because the concepts are from IGs, तो I took this liberty कि I'm sure कि अब थोड़ा कैच अप कर सकते हैं इसको. बट स्टिल अगर किसी बच्चे का कोई डाउट होगा आप मुझे इनबॉक्स कर सकते हैं, ग्रुप में नहीं पूछें बेशक. अपने जो पर्सनल डाउट्स और क्वेश्चंस हैं वो आपने मुझे इनबॉक्स करना है, ग्रुप में नहीं शेयर करेंगे. तो अब बिकॉज यू आर इनटू योर मिड टर्म्स, on exam day normally teachers are not there, subject teachers. But अगर कोई ऐसा part और question आता है which you feel like you have not done, you guys can leave it, but eventually make sure कि you leave it uh, only if that thing is not touched at all in class, right? फिर मैं देख लूँगा उसको, कोई ऐसा इशू नहीं है. बिल्कुल लास्ट मिनट है, किसी का कोई क्वेश्चन है डाउट बेटा पूछ लें. रिकॉर्डिंग में शेयर कर दूंगा ग्रुप में. जो बच्चे नहीं अटेंड कर पाए, वलीद वाज ट्राइंग बट उसका कोई नेट का शायद इशू था या कुछ.
सर आपने केमिकल बॉन्डिंग का एक कॉन्सेप्ट बताना था कि अगर लेट्स से उन्होंने एमसीक्यूज में किसी शेप का उन्होंने मेंशन किया हो, उसका एंगल उन्होंने ऑप्शन में ना लिखा हो, तो
हाँ
कौन सा ऑप्शन
बिल्कुल,
चूज
अगर
करना है?
सेट एंगल ऑप्शन में नहीं है एंड यू हैव लोन पेयर, तो फिर आप उससे स्मॉलर एंगल पिक करेंगे बिकॉज लोन पेयर एग्जर्ट मोर रिपल्शन। वो एक पॉइंट है, वो उसमें दो तीन एमसीक्यूज हैं, ज़्यादा नहीं है।
ओके।
सो इफ सेट एंगल इज नॉट देयर, गो फॉर स्मॉलर एंगल इफ लोन पेयर इज देयर।
ओके सर।
चलिए बेटा, क्लास